Okay, so today we'll understand the concept of limit. What is the meaning of limit? For example, we might have seen many places in our textbook at x arrow a. So we'll try to understand what is the meaning of that. So our topic name is limit. So before jumping to the main content, let us try to understand the idea behind the concept of limit. What is the actual meaning of limit? Let us try to observe first of all if we can feel the concept of limit, if we can somehow relate it with some real life example. So first we'll try to understand that, and then we will move to the theoretical part, move to the actual formulation of the concept of limit. So let us say if I am standing here and this is the board. So let us say I am approaching to the board. So I am X and this is my point A. So after every time my position will change. At this particular time I am here. So after some time I'll be at this place. After some time I'll be at this place and so on. So what I am interested in knowing how I am approaching the board. So I am not interested in knowing the where I am at this point A, but I am interested in knowing that how I am approaching that point. For example, if we take the example of a function, say fx is equal to 2x plus 1, and I want to know, or maybe for simplicity we can take fx is equal to x. So very basic example. So for example, if we try to observe the behavior of this function as x goes to 0. So what basically the general mistake is why directly substitute the value over here. For example, if I want to know the behavior of this function when x is going towards 0, then what we do usually, we just substitute the value 0 and we say the function is 0 when x is going to 0. So let us draw the graph. So the graph of fx equal to x looks like this. So what we generally do, we directly substitute the value that when x is going to 0, fx is also going to 0. So this is a general mistake. But here direct substitution is working. The limit, if we calculate the limit actually, limit fx x goes to 0, this also will come to 0. So here direct substituting 0 is same as the value of the limit. So here things are going with easy. There is not any difficulty in that. But for example, if I take my function to be like this, say x square minus 4 upon x minus 2, and if I ask what is the value of this function at x equal to 2, or if I ask what is the behavior of this function where the function goes when x approaches 2. So if we directly substitute the value of x equal to 2 in this function, then we can see the denominator and numerator both are becoming 0. Here if we substitute 2, so it will become 2 square minus 4 upon 2 minus 2. So numerator also we can see is 2 and numerator also we can see is 0 and denominator also we can see is 0. So the value is, we can't calculate the value by directly substituting. So we need to calculate the behavior. So at x equal to 2, the value of this function we don't know. It is not defined. So but we are not interested in that at all. We are not interested to know what the value the function is taking at x equal to 2. That is not our domain of interest. What our domain of interest is how the function is behaving when x is going towards 2, not at 2. We don't know. We just want to know when x is moving towards 2, we can make the distance as small as we want. So how the function is behaving in that way. Let me draw graph of a function. So if we do a little bit of calculation, it is x minus 2, x plus 2, x minus 2. So this is x plus 2 when x is not equal to 2. This is the value of the function. Fx is x plus 2 when x is not 2, because we can cancel these two terms only if x is not equal to 2. But if x is equal to 2, then we cannot cancel these two terms. So this function is defined for all x when x is not equal to 2. Now again we need to calculate the limit of fx when x approaches to 2. So here everything is fine for us, because at x equal to 2 particularly this function is not defined, because it will become 0 upon 0, that makes no sense. So at x equal to 2 this function is not defined, but at any other points except x equal to 2 the function is defined, and it is x plus 2. So in the concept of limit, like just I told, we are not interested actually how function is behaving at x equal to 2. For example, in this function at x equal to 2 the function is not defined at all. So but it was not a problem for us, because we are not interested at the value of the function at x equal to 2. We are just interested how the function is behaving when x is approaching to 2. So now the limit of the function when x is approaching to 2 is nothing but 2 plus 2, which is 4. Now let us see graphically. Let us say this is 0, this is 1, this is 2. So when x is equal to 0, fx is 2, this is 1, this is 2. And when x is equal to minus 2, my function is 0. Minus 1, minus 2, like this. But it is moving like this, but at x equal to 2 the function is not defined. So at x equal to 2 I don't know the value of x, and at remaining other points my function is like this. Only the problem is at x equal to 2. So now understand the graphically. Here we can see at x equal to 2 the value of f is not defined, right? At x equal to 2 the value of f is not defined, but I am not interested in that. I am interested how the function is behaving when x is approaching towards 2. So let's see from this side, left hand side. When left hand side I am, for example, I am standing here. This is my point where I need to check the value. So I am moving like this from left side. I am moving like this, I am moving like this, I am moving like this. Like whenever I go as close to 2, at 2 the value is not defined, but whenever I go as close to 2, then the value of the function will go as close to 4. This is 4, this is 3. So from left side, if I approach towards 2, my function is approaching towards 4. And similarly, from the right side, this is the graph. So when I am moving towards x equal to 2, then also my function is going to x equal to 4. And here also we can see when x is going towards 2, the value of function is going towards 4. So we say the value of limit when limit of this particular fx when x is approaching to 2 is nothing but 4. So this is the idea of the limit, how the function behave near to that point but not exactly that point. Here direct substitution was working. We directly substituted x equal to 0 because the function was continuous. But here the function is not continuous at x equal to 2. Hence we cannot directly substitute the value x equal to 2 here, and we can see how the problem we were facing. We cannot cancel these two quantities when x is equal to 2, because we cannot cancel 0 and 0 in numerator and denominator. So this is the idea of the limit. So here I have said one more thing. Okay, we were approaching from the left and we were approaching from the right. So here comes the idea of left hand limit and right hand limit. So let us see what is the meaning of that. So left hand limit is generally denoted by LHL. It means left hand limit. And how it is represented? Limit of fx, x goes to a minus, and right hand limit, limit of fx, x goes to a plus. So what is the meaning of left hand limit and right hand limit? Left hand limit means we are approaching to a from left side. For example, in the case of this function at x equal to 2, when we are approaching to 2 from left side. And what is the value of function? 4. The function value of function is approaching 4. And when we are approaching to this value 2 from right side, then also the value of the function is approaching to 4. At 2, we don't know. From left side it is 4, from right side it is 4. It means LHL, left hand limit, in this case is equal to the right hand limit. And if left hand limit and right hand limit comes out to be equal, then only we say that the limit of the function exists. For example, in some cases this might not be true. For example, I take my function gx, it is like this, say x equal to 1. Maybe like this. So when x is less than 1, then it is x, and when x is greater than 1, maybe it is x plus 1. Okay. So here we can see at 1 the function is not continuous. This is g. Okay. Now what about the limit? What about limit gx as x approaches to 1? Now we are interested in finding out the limit of gx as x approaches to 1. At 1, let us do this. Okay. So if we calculate the value of gx at x equal to 1, so what is the value at x equal to 1? It is 1 plus 1, which is 2. So g of 1 is 2. Okay. But again here at 1 the value is defined, but in this case we can see the value at 2 is not defined. So we are not interested in that. At point 1 how the function is behaving, we are not interested in that at all. We just need to check the limit of the function, how it is behaving when x is moving towards 1. So in this case we need to find left hand limit LHL and right hand limit RHL. So what is the meaning of left hand limit? Limit gx x goes to 1 minus. It means here we can see from the left side, this is our left side, minus means left side and plus means right side. So this is our left side. So if we can see, if we are approaching to 1 from the left side, it means we are moving from here like this. So where the function is going? The function is going like this. This value is 1 and this value is 2. So when we are moving to 1 from left side, the function is going to 1. So this is 1. And when we are moving from right side, so if we are moving from right side, so how my function is behaving? My function is behaving like this. So let us see when we are moving from right side, as x approaches to 1 from right side, from here. So we can see the value of my g is going towards this point. From here also we can see left side means less than 1. So when it is less than 1, it is x. So we are going towards as 1. If we see x is going to 1, so fx gx is equal to x is also going to 1. And if we can see from here, if we are going from right, then the gx is x plus 1. So when x goes to 1, x plus 1 goes to 2. So here my value is 2. So now we can notice here the difference. Here left hand limit, the value of function from the left side when approaching from left side goes to 1, and the limit of the function gx when goes to 1 from right side goes to 2. So here these two things are unequal. This is 1 is not equal to 2. It means left hand limit is not equal to right hand limit. Hence we say the limit of the function gx does not exist at x equal to 1. So here we write limit of gx does not exist at x equal to 1. When we are approaching to 1, so the limit does not exist, because left hand limit exists, it is finite, which is 1, right hand limit also exists, that is also finite, which is 2. But since these two quantities are unequal, hence the limit of the function does not exist. So if we take any point except 1, if we are taking any point less than 1 on the negative side or on the positive side, so let us say we are taking maybe 5. So if we are taking 5, then we can see if we extend the graph. So at 5, whether we are going from left side or we are going from right side, at near 5 the function the gx is x plus 1, so it would be going towards 5 plus 1, which is 6. So extend this also, maybe here is 6. So at x equal to, when x approaches 5 from the left side, the left hand limit also comes out to be 6, and when x approaches 5 from the right side, again the value come out approaches, the value of gx approaches to 6. So if we need to calculate the limit gx when x approaches to 5, this would come out to be 6. Or we can take any point to the left side of the 1, maybe minus 1. So if we need to calculate the value of the limit gx as x approaches to minus 1, so the function would, since it is less than 1, it would behave like this x, so it would be minus 1. So here we can see how the gx is behaving. At x equal to 1, the limit does not exist, while at any value except 1, the value of the limit exists. So what is the concept of limit? We are not interested in knowing what value the function is taking at that point, but we are interested in knowing how the behavior of the function is in a neighborhood of that point. So like here, this was a very good example. The value at this point we do not know, it does not exist, but we want to know how the function is behaving in the neighbor of this point, and we calculated the limit fx x goes to 2. This came out to be 4. So this was all about limit. So hope you understood. Thank you.